For this first problem, if you look, I have an x and a negative x. So if I just add these, since the numbers out in front are the same, they're both technically a 1, and I have a positive and a negative. If I just add these, those x's are going to cancel out. So I add x plus negative x, they cancel. I have 1y plus negative 3y, that's negative 2y. And I have 7 plus negative 11, that's negative 4. When I divide by 2 on both sides, I get that y is 2. Then I need to plug back into one of these, so I'm just going to choose this top one. I have x plus, I'm going to plug in 2 for y equals 7. I subtract 2 from both sides. I get that x is 5, and so my ordered pair for this problem is 5, 2. On the second problem, if I look at my x's, I have a 1 and a 3, so those won't cancel out. And then I have a positive 2 and a negative 1, so those aren't going to cancel either. So I need to figure out which one of these I'm going to multiply. And the easiest one, since I have a positive and a negative, would be these y's. So I want this negative 1 to become a 2. So I'm going to multiply each of these by 2. When I do that, I have 3 times 2 is 6. Negative 1 times positive 2 is negative 2y. And 9 times 2 is 18. And then if I rewrite this one right below it, now I can add. And these y's will cancel out. So I have 6 plus 1 is 7. The y's are going to cancel, equals 28. I divide by 7 and I get x is 4. And I'm going to take that and plug it back in. I'm just going to plug into the top. So I have 4 plus 2y equals 10. I subtract 4 from both sides. I get 2y equals 6. And when I divide, I get that y is 3. So my ordered pair is 4, 3. For the third problem, again, I'm just going to kind of look at, I have a positive x and a positive x. I have a 3y and a 1y, and they're both positive also. And so since these x's both have a 1 in front of them technically, I just need one of them to be negative. So if I were to multiply this first equation all by negative 1, it would just flip all the signs. So then I would have negative 1x minus 3y and positive 4. And these are going to cancel out. So my x's are going to cancel. I have y minus 3y, so that's negative 2y. 0 plus 4 is 4. And if I divide both sides by negative 2, I get that y is negative 2. I'm going to plug it into this one. When I do that, I have x plus negative 2 equals 0. I would add 2 to both sides. X is 2, so my ordered pair is 2, negative 2. On this problem, if I look, I have a 1x and a 5x, so those are not going to cancel. And then I have a negative 1 and a positive 1y, and so those will cancel if I just add. So I have x plus 5x is 6x. Negative y plus y will cancel. Negative 3 plus 9 is 6. When I divide both sides by 6, I get x is 1. If I plug that back in here, I have 1 minus y equals negative 3. I would subtract 1 from both sides. I have negative y equals negative 4. And when I divide both sides by negative 1, I get y equals 4. So this one would be 1, 4. For this example, you're going to multiply the bottom equation, each number by negative 14. So I get negative 14x plus 70y equals negative 154. And then I rewrite the first equation right below it. And when I add, the x's cancel. I get 72y equals negative 144. And when I divide both sides by 72, I get y equals negative 2. Then I want to plug that back in, so I'm going to plug it into the top equation. Two times negative 2 is negative 4. I add 4 to both sides. I get 14x equals 14. And when I divide, I get x is 1. So my ordered pair is 1, negative 2. When I solve this system of equations, I can see that I have the positive negative here, but I have 3 and 6. So I can easily make this 3 a 6 if I multiply by 2. So I'm going to multiply the entire top equation by 2. I get 8x plus 6y equals negative 12. Then when I add the two equations, I get 5 plus 8 is 13x. This negative 6y plus 6y will cancel, and negative 27 plus negative 12 will get me negative 39. And when I divide both sides by 13, I get x equals negative 3. I'm going to plug that back in. I'm just going to choose the top one. I have 4 times negative 3 plus 3y equals negative 6. 4 times negative 3 is negative 12 plus 3y equals negative 6. I would add 12 to both sides. I get 3y equals 6. And when I divide by 3, y equals 2. So this ordered pair is negative 3, 2. For this system, if I look, I have a negative 4 and a positive 4x, so I can go ahead and just add these right away. I don't need to do any multiplying. Negative 4x plus 4x is going to cancel out. Negative 2y plus 2y also cancels out. And 0 plus negative 11 is negative 11. Now, on the left side, since all this stuff canceled out, I actually technically have a 0 here. And I read this, it says 0 equals negative 11. And that doesn't make sense, so this would be no solution. For this system, if I look at the x's, I have 1x and 1x. So the only thing I need to fix is I need one of those to be negative. So if I multiply the top equation all by negative 1, and rewrite it down here, I would get negative x plus 4y equals negative 1. Now I have my 1x and negative 1x, so I can go ahead and just add. So 1x plus negative 1x will cancel. 2 plus 4 is 6y. 13 plus negative 1 is 12. When I divide, I get y equals 2. And when I plug that back in, I'm going to get x equals 9. On this system, if I look at my x's, I have 3x and 5x. If I look at my y's, I have negative 1y and then a positive 2y. So if this top equation were to have a negative 2y, those would cancel. So that means I want to multiply the entire top equation by 2. When I do that, I get 6x minus 2y equals 0. And now since I have positive 2 and negative 2, I can add, and those will cancel. So I'm going to get 11x equals 44. I divide both sides by 11, x equals 4. Then I'm going to plug that back in. So I have 3 times 4 minus y equals 0. 3 times 4 is 12 minus y equals 0. I subtract 12 from both sides. I get negative y equals negative 12. And when I divide both sides by negative 1, y equals 12. So this ordered pair would be 4, 12. For this system, I have 1x and 4x, and I have positive 3y and negative 2y. And so I could easily change this 1 into a 4. But since this 4 down below is positive, I want this 4 up top to be negative. So I'm going to multiply the entire top equation by negative 4. I'm going to rewrite that right below. So I get negative 4x minus 12y equals negative 32. And now I can go ahead and add those because my 4's will cancel out. I get negative 14y equals negative 28. And when I divide both sides by 14, I get y equals 2. And so when I plug that back in, I get x plus 6 equals 8. And when I subtract 6 from both sides, I get x is 2. So this ordered pair would be 2, 2. For this system, I have 2x and negative 2x. So since those match up, but one's positive and one's negative, I can go ahead and just add, and those will cancel out. So I have negative 2 plus 3, which is y, and 4 plus 6 is 10, so y equals 10. When I plug that back in, I get negative 2x minus 20 equals 4. I add 20 to both sides. Negative 2x equals 24. I divide by negative 2. X equals negative 12. So this solution would be negative 12, 10. For this example, if I look, I have a 3x and a 1x, so I could really easily make this 1x a 3 if I multiplied by 3. But since this top 3x is positive, I want this one to be negative, so I'm going to need to multiply each by negative 3. When I do that, I'm going to get negative 3x plus 9y equals negative 27. And then I'll want to rewrite this right below. And now I'm ready to add because I have negative 3x and a positive 3x. So those are going to cancel. 9 plus 2 will get me 11y. And then negative 27 plus negative 17 would get me negative 44. When I divide both sides by 11, I get y equals negative 4. Then I'm going to take that and plug it back in. And so that would get me 3x minus 8 equals negative 17. I would add 8 to both sides. 3x equals negative 9. I divide by 3. X equals negative 3. And so this solution is negative 3, negative 4. For this system, since I already have a negative y and a positive y, those are going to cancel. So I can go ahead and just add. So x plus 2x is 3x. Negative y plus y cancels. 11 plus 19 is 30. I divide both sides by 3. X equals 10. When I plug that back in, I get 10 minus y equals 11. I can subtract 10 from both sides. Negative y equals 1. When I divide both sides by negative 1, I get y equals negative 1. So the solution to this system is 10, negative 1. On this system, I look at the y's and I see I have negative 9 and negative 9. So since the numbers match up, I'm almost getting them to cancel. But I need to be one to be positive and one to be negative. So if I were to multiply this top equation all by negative 1, all these signs would change. And then I'd be able to add each equation and get the y's to cancel out. So I have 2 plus -4, so that's -2x. The y's cancel. 25 plus -23 is, +2. And when I divide both sides by -2, I get x equals -1. If I plug that back in, I get 4 minus 9y equals -23. I subtract 4 from both sides. I get -9y equals -27. And when I divide by -9 on both sides, y equals 3. So the answer to this system is -1, 3. This problem is really similar to the last one. So if I look, I have a +1y and a +1y. So again, if I were to multiply this top equation all by -1, it's just going to flip all the signs. So I would have -8x minus y equals 16. And now I have a +y and a -y. So when I add, those will cancel out. -3x minus 8x is -11x. Like we said, the y's are going to cancel out. -5 plus 16 is 11. When I divide, I get x equals -1. I can plug that back in. I get -8 plus y equals -16. I add 8 to both sides. Y equals -8. For this problem, I have -6x and a -6x. So again, if I were to multiply the top equation all by -1, I would get 6x minus 6y equals -6. And now I have a -6 and a +6, so when I add, those will cancel. I have 3y plus -6y, so that's -3y. -12 plus -6 is -18. If I divide both sides by -3, y equals 6. When I plug that back in, I get -6x plus 36 equals 6. I subtract 36 from both sides. I get -6 equals -30. When I divide by -6, x equals 5. So the solution to this system is 5, 6. On this system, I already have a -2y and a +2y. So since the numbers match, but I have a negative and a positive, I can go ahead and just add. I have -7x plus 8x, so that's 1x. -2 plus 2y is going to cancel like we said. -24 plus 30 is going to be 6. So x equals 6. You plug back in. -7 times 6 is -42. Minus 2y equals -24. You add 42 to both sides. -2y equals 18. I divide both sides by -2. Y equals -9. For this system, I have a -7y and a 1y. So since one's positive and one's negative, I just want the top equation to have a 7y. So if I multiply everything by 7, I'll get 7y, and those y's would cancel out. Then I'm going to add. I get 45x equals 45. I divide both sides by 45, and x equals 1. When I plug that back in, I get 5 plus y equals 9. I subtract 5 from both sides, and y equals 4. So the solution is 1, 4. On this example, I have a negative 4x and a 1x, and so I want there to be a 4 out in front here, so I'm going to multiply each of these by 4. That'd get me 4x minus 12y equals negative 24, and then I'll rewrite this equation right below it. And now when I add, those x's will cancel out. I'll have negative 3y and negative 15. I divide both sides by negative 3, and y equals 5. When I plug that back in, I get negative 4x plus 45 equals 9. I subtract 45 from both sides. Negative 4x equals negative 36. And when I divide by negative 4, I get that x equals 9. For this example, I have a plus 1y and a positive 3y. So I want this to become a negative 3. And so I'm going to do that by multiplying the top equation by negative 3. That would get me 21x minus 3y equals 57. Now I can add these. I get negative 2x plus 21x, and so that gets me positive 19x. These 3's cancel out. Negative 19 plus 57 is 38. When I divide both sides by 19, x equals 2. When I plug that back in, negative 2 times 2 plus 3y equals negative 19. So that's negative 4 plus 3y equals negative 19. I add 4 to both sides. I get 3y equals negative 15. And when I divide, y is negative 5. On this system, I have a 14y and a negative 7y. I could turn this negative 7 into a 14 if I were to multiply each by 2. When I do that, I get negative 12x minus 14y equals negative 20. And then I can rewrite this equation right below it. And now when I add, those 14y's will cancel out. I will have negative 4x left and negative 16. And when I divide by negative 4, I get 4. When I plug that back in, I get 32 plus 14y equals 4. I subtract 32 from both sides. 14y equals negative 28. And when I divide, y equals negative 2. On this system, if I look at my x's, there's no easy way for me to multiply one of the equations and get the other number. And the same thing happens for the y's. So I'm actually going to have to multiply both equations in this case. Since my negative 8y and positive 9y are the opposite sign, the negative positive, I'm just going to go ahead and try to cancel those out. So if I multiply the top equation all by 9 and the bottom equation all by 8, and then you kind of look at what happens, I would get negative 63x minus 72y equals 81. The bottom equation, I would get negative 32x plus 72y equals negative 176. Now if you look, I have this negative 72 and this positive 72, so those will cancel out. So I have negative 63x plus negative 32x, and that's negative 95x. Like I said, the y's will cancel out, and then I have 81 plus negative 176, and that is negative 95. When I divide by negative 95, x equals 1. I'm going to plug that back into this bottom equation, which gets me negative 4 plus 9y equals negative 22. I add 4 to both sides. 9y equals negative 18, which means that y is negative 2. Just like the last problem, there's no easy way to just multiply one equation and get something to cancel out, so I'm going to have to multiply both equations. I'm going to cancel out my y's again since I have a positive and a negative. So I'm going to multiply the entire top equation by 9 and the entire bottom equation by 4. So I get 45x plus 36y equals negative 270. And I get 12x minus 36y equals negative 72. When I add 45 plus 12, I get 57x. I have positive 36 plus negative 36, so those cancel. And negative 270 plus negative 72 is negative 342. When I divide both sides by 57, I get x equals negative 6. When I plug that back in, I get negative 18 minus 9y equals negative 18. When I add 18 to both sides, I get 0. And when I divide, I'm still going to have 0. And so the solution is negative 6, 0. For this system, you could have multiplied the bottom equation by 4, but I decided I'm going to get rid of my y's, so I chose to multiply the bottom equation by 3 because that will get me this negative 15, and then it'll get me a positive 15, and those will cancel. So when I do that, I'm going to get negative 3x plus 15y equals negative 39. And then I'm just going to rewrite my second equation right below it. When I add, I'm going to get negative 7x. My y's cancel out. And negative 39 plus negative 17 is negative 56. When I divide both sides by negative 7, I'm going to get x equals 8. I'm going to plug that back in to the second equation, and I get negative 8 plus 5y equals negative 13. I can add 8 to both sides. I get 5y equals negative 5, and when I divide, y equals negative 1.